Yeah. How's that now? Okay, cool. Alrighty.
Might have to turn off the front.
Sure. Yeah.
Okay,
It was already off.
I don't know which one I usually turn off. I guess that.
Yeah, this is good. Leave it. All right. Okay, getting started now. So my name is Liam Ramsey. I'm a physicist, but most people assume I'm not. I do computer stuff all day, including people in my physics group assume I'm an engineer. But today I'm going to be talking about Homelab, which has a fair bit of relevance to Linux because, well, most servers on the internet run Linux. Realistically, if you're connecting to a connected service, it's either Linux. If it's a bank, maybe it's some godforsaken mainframe. And if it's a company stuck in 2005, maybe they're actually still running Windows Server.
If it's Reddit, it's also Windows.
Really?
Because Reddit runs on 4 Windows servers with IIS.
Oh, that's cursed. Okay.
So that's why it never works.
Well, Stack Overflow does the same thing. Oh, it's Stack
So that's why it never
No,
works.
All
I
right.
know the name wrong.
Well, we'll start with defining what a server is, just to keep this talk accessible and not jump right into like reproducible deployments with Nix. I'm not going to mention that at all. What's a server? It's a fair question because it's, this is my attempt at a definition. I think it's like an operating system. If you get a 20 CS majors in a room and ask them to define an operating system, you get 21 answers.
No. At least 20 seconds.
Yeah. So, in general, a server is just a computer, as the computers we're using right now, but it's geared towards running a service for other computers. So an example of that would be a website. Some other computer somewhere has to give you the HTML and other data to load a website. So that's a web server. Typically, servers have a couple properties. They are typically headless. You can access a server with a GUI, but most of the time people don't particularly bother. They just have some box that they SSH into and control via CLI, command line interface. They often run 24/7. People like their uptime. You don't want to not be able to access the website because the engineers turned it off before they left for the day. They typically try to run them all the time. And as I interacted with via terminal. So that said a little bit about what a server is. It just runs some programs to be accessed by other computers. Why might you want to run your own? Well, you may want to take control of your data. So obviously Google and many other companies, you can have all kinds of stuff hosted with them. They can do your backups, photo management, all kinds of fancy things. But if you have a preference, you may want to run all those things yourself, and you can. There are a significant number of open source projects that let you do this, and I'm going to talk a bit about a couple of them. You can save some money. So if you're paying for expensive cloud storage, you could build a server with a fair amount of storage for a lot less than you pay. You will lose some time. There's a common saying that Linux is free if you don't value your time. You will have to kind of learn what you're doing and spend time on that. But you learn skills doing it. And you can run things also that companies either won't or can't do. I think many of us have probably had some frustrations of being like, why doesn't company X just do this? It would be great. So you can kind of take control over how it works, how you handle it, and gives you a lot of freedom to try to build what you want. So what do people do with these servers once they build them or do anything with them? They run game servers. That's at least how I got into it years ago as a middle schooler, figuring out how to run a Minecraft server. I had no clue what port forwarding was, no clue what I was doing. Eventually made it work. Photo management. If you want to store your photos, have them all indexed all nicely, basically a Google Photos-like service, there is a very good one that's open source now called Imich, IMMICH. I've been using them for a bit. File backups, again, many other services let you do this, but you can sort of run your own backups and have them with whatever frequency, no storage limits, etc. You can run your own personal website. Sure, there's places you can pay to host it, but you can also host it yourself. You can just have whatever content on there. If you want to put a 500 gigabyte file on there for people to download, then you can. It's how I tend to share big files actually with people because everything has a file size limit. Home automation. So if you want to run a smart home and you want to do it not tied to any specific manufacturer, you can do it with Home Assistant. So I, for example, have my room programmed for the lights to slowly come on in the morning when I wake up, or my lights turn off when my phone leaves the Wi-Fi, they turn on when my phone comes back to the Wi-Fi. So you can just set up all kinds, and that's a pretty trivial automation. People go crazy with these things. So you can have a fine-grained control over that. Video streaming. So let's say you sail the high seas and you have a number of movies and TV shows stored somewhere in a file, but you don't want to haul around a hard drive with all of them or somewhere. You could have a central location that just streams it to your web browser. Okay, it could be your completely legitimate set of ripped Blu-rays that we obviously all have. All those Linux ISOs. And much more. There's as many things that you can do with a server as real servers do. And I can say real server, this is a real server, but that major companies do. Because all that just runs on a computer. The cloud is just someone else's computer. You can make it your computer. So I can give a little bit of overview here of what I'm going to talk about. I'm going to talk a little bit about just getting started. What does it mean to get a server? What counts as one? What could you make into a server? Data storage, that's often a big part of it. It's often a motivation a lot of people have to make a server is to store some large amount of data that they don't want to handle. You're just on their laptop or run backups. Networking, it's a pretty common task because if you want to run a connected service, you have to somehow let people connect to it. So there's almost always some amount of networking involved in home labbing. Cloud services, although home labbing is kind of thought to get away from the cloud, sometimes the cloud does have a place in home labbing. Managing your home lab, because it does require some amount of management. I mean, their IT people have jobs for a reason. These things do take a bit of maintenance, and it's good to outline what that kind of entails, what kind of commitment. Mentioning a list of more or less popular services that you may be interested in if you want to run things, maybe you already have a home lab. I could be something you haven't heard of before, or just maybe presenting a couple things that maybe interest you in actually setting one up. And then some random online resources where you can maybe find more information. So jumping into it, getting a server. Pretty much anything works. It just needs to be a computer. And you can kind of put Linux on a lot of things. Some things easier than others. Maybe don't start with like an M1 Mac, but you can kind of just grab any old computer off the side of the road, throw Linux on it, and it can be a server. It doesn't take much to run a website. So old laptop, desktop works fine. That's how I started out with an old laptop. I know plenty of people who use old desktops. Raspberry Pis can work. They're low power. I wouldn't recommend running a Paddle World server because you're going to need like 20 gigs of RAM. But it can run a fair amount. Or you can just build a custom build. Just throw together a PC like you would build a desktop gaming PC. And there you go. You can spec it out to what you want. Or also an enterprise server. You can actually get the servers that people run in data centers. They're loud. Do not underestimate how loud those fans are. So maybe don't start with those, but it's certainly an option if you want like a big rack-mounted enterprise-like setup, more of a home data center than a home server. You'll probably want to prefer Ethernet or some other wired solution. Wi-Fi doesn't have good latency performance, so a lot of connected services won't perform as well over Wi-Fi. It works well for a number of things, but file servers, for example, are very latency sensitive. And it's a big difference having 5 millisecond ping versus 30 millisecond ping when you're trying to access a network file system. So go hardwired whenever you can. And then you can kind of just install Linux. There's a number of server OSs out there, but you can basically make any Linux system into a server. It really just involves running the programs that serve the content to other computers. So now I'll talk a little bit about storage. So if you're storing a fair amount of data, it starts to be a bit of a process in of itself. You can't just stick a USB hard drive on there. You can maybe start out with that, but once you have multiple terabytes of data, it warrants more careful consideration. So you want backups. If you don't have backups, then you're fine with losing the data. That's the trade-off you have to make. It's not if a hard drive will fail, it is when. Hard drives will fail. They always do. I don't care if you've had it running for 10 years and you've dropped it twice and it has 0 bad sectors. It'll die eventually. Hosted content, or you're just data hoarding. There's a whole subreddit to people who just download entire YouTube channels in case they disappear. That's some people's hobby. So there's a number of things you may want to You may have a lot of data that you want to store, and it warrants, again, more thought than just a USB drive. So here's a couple things you may be thinking as to why I don't want to run my server. Why can't I just use a bunch of external drives? Just go grab a bunch of Western Digital USB drives, plug them in via USB, and just store all the stuff on them, keep them in a drawer somewhere. Or just use Google Drive, or just whatever storage you have on your laptop. So reliability is a big problem in external drives. They are not reliable. They fail at a much higher rate than server-grade drives or even just consumer-grade drives you put in a desktop. With Google Drive, again, if you're fine with somebody else having access to your files as in some other company, then sure, that can work for you. Google does read what you put on there. They will remove copyrighted files from your Google Drive, so they obviously are able to scan all of them. And for a while, you could get banned from Google if you put a file that just was named 1, because for some reason that had a hash that was in their database. But, or again, with storage on your laptop, reliability and availability. So your laptop, that's one point of failure. With availability, maybe you want these files to be accessible at more than one person, or just generally available all the time, not just when your laptop's sitting there running. I'm gonna ditch the microphone. It's annoying to talk into. I'll just talk louder. Okay. So some terms to know that get thrown around a lot in this space, just in general related to running your own storage server. NAS, you will hear NAS a lot. It just means network attached storage, okay? So there are companies that make purpose-built NASs. They are just small servers that are storage geared, and you can run other stuff on them too. You can put Home Assistant on there for your home automation. Synology makes a number of these, and they're a rather popular option. And so if you want a storage server, but don't want to worry about configuring it all yourself, it's sort of a middle point. You can still have your own server, but just let a company simplify it a bit for you and just pay a bit upfront cost to get that peace of mind. Another acronym, a little bit less common, is a DAS, or direct attached storage. So you can kind of think of it as some external thing that lets you plug a bunch of drives in. And then you can plug that into your computer. So you kind of think of it like a USB, hard drive cage, and you just can put drives into the front of it, plug it in via USB, and now those drives are on your server. Those can be tempting because you may want a Raspberry Pi and then a bunch of drives, and that seems like a good option. I've had some bad experiences with these specifically. They tend to use pretty buggy drivers for the USB attached SCSI in the kernel. I went through a whole rabbit hole of reflashing it using the sketchy Chinese manufacturer's software and everything, and I couldn't get it to. I kept getting read-write errors. So I would caution against USB drive cages. Sometimes they work, but when they don't work, it's a big pain, and then you're out a couple $100 on a drive cage like I might be. Another thing you'll hear sometimes is SAN, S-A-N, for storage area network. This is far less common in home labbing situations. This is more when you're approaching home data center. But it's when you might have one whole rack full of drives and then another rack full of servers that want to access those drives. So you can sort of have a separate network backbone between a whole bunch of things that hold drives and network that storage over these high-speed, InfiniBand-like connections to other servers. But that's overkill. Again, that's home data center level. But just so you're kind of aware of what that is, because it does get thrown around sometimes. And then another one, which I would say might be the most important on this list, is RAID. RAID stands for Redundant Array of Inexpensive Disks. And this guards against drive failures. So let's say you have all this important data on your server, and as I said, hard drives fail. So what do you do if hard drives fail? Well, backups. Backups are always something you must have, and RAID is not a substitute for that. But what RAID does is you can set up an array of hard drives, and they can keep parity data distributed among the drives, such that one drive could fail and you won't lose any data. So you kind of sacrifice some storage space for redundancy, okay? So here's a bit of an illustration and breakdown of a couple types of RAID, okay? So there's RAID 0 that gets thrown around. It's kind of like not RAID, really. RAID 0 means striping the drives together. So they actually store completely independent data, which means if you lose one drive, you lose all of the data on all of the drives. But people still do it because it gives you a lot of speed. So I mention it here for completeness. It doesn't have much context in terms of servers, but plenty of gaming computers and such will want the gigabytes of write speed per second. They'll RAID 0 some SSDs, and then they just double their failure risk, but that's still relatively low on modern SSDs.
On something like games, you probably don't care. 'Cause
Yeah.
just pull it again.
Yeah, you can just download your games again. So your game drive could be a fast RAID 1 thing, so you can load into Cyberpunk 2077 in this century and just let it rip. RAID 1 is also is actually used a fair bit more in servers, and it's kind of the opposite of RAID 0. So RAID 0, you can take two 1 terabyte drives and you get one faster 2 terabyte drive. It combines the storage. RAID 1, if you have two 1 terabyte drives, you now have one 1 terabyte drive. It just duplicates the data on each drive. So this is a pretty easy way to guard against drive failure because you just make the drives identical, and if one of them dies, you just go replace that one. Okay? But that doesn't necessarily scale well because the capacity is equal to 1 drive. So you can even put like 5 drives in there, but then you have 5 terabytes of storage, but you can only use 1 terabyte. So that's not terribly efficient. So the others sort of meet in the middle. So RAID 5 gives you reasonably good performance, and it gives you 1 drive worth of failure. And you can actually scale that up to a fair number of drives. So you could have an array with 5 drives, and any one of those 5 could fail. And you get the capacity of 4 drives. Okay? So if you had 5 terabyte drives, you would have 20 terabytes of storage, and any one drive could fail. So it's very handy because a drive will fail. You get a lot of storage, and when a drive fails, you don't lose uptime. You can just, with some servers, you can even just pull the drive out while it's running, plop in the new drive, click a button in the web UI or something, and it will rebuild the parity on that new drive. However, once you start getting to larger drives, I wouldn't recommend RAID 5. So once you start getting more than 4 terabytes or so per drive, that rebuild process of repairing the array after a drive failure can actually take a very long time. And it's very punishing on the drives. They're doing a lot of activity. And once you get to up to 20 terabyte drives, it could take a couple days to rebuild it. And that's a couple days of the drives running at 100%. And when one drive fails, the others could be close to failure. And if you lose another drive during that rebuild, now you've lost data. Now it's gone. So RAID 6 gives you that extra buffer and is generally recommended if you're using drives larger than 4 terabytes. And that has 2 drive failures, but you sacrifice 2 drives worth of capacity. So that's essentially what I have at home. I have 5 4 terabyte drives in RAID 6. So I have 12 terabytes of usable storage, and any 2 of them could fail. And I have had a drive fail because someone bumped into my server rack at a party. And so, no, it's off in the corner. Just somebody. It was also in the corner of what became the dance floor. So, yeah. So RAID is something to consider if you want a lot of data capacity. If you want a lot of storage, you likely are going to go for a RAID system. You don't buy one 20 terabyte hard drive. You can get some performance and reliability assurances by getting a bunch of smaller drives and combining them. Now speak a bit more about software in the storage space. So there are some storage-centered operating systems you can run on your server. If you just want to you're really particularly interested in storage and you don't want to build it all up yourself, you can choose some of these more storage-focused operating systems. FreeNAS is one of them. Sacrilege, though, it's not Linux. It is FreeBSD-based, but it's at least Unix-like. Unraid is another. I'm not the biggest fan of Unraid. They kind of take a different approach to distributing data across drives. It's a little different from RAID, but a lot of people use it. So I put it up there. As well as related to actually configuring this RAID. So that's worth speaking about for a moment. A lot of motherboards can do RAID. So you can say, hey, motherboard, set up all these drives in RAID 5. I don't recommend that, though, because that RAID information is saved to the motherboard. It is tied to that motherboard. If you move those drives to another system, it's done. You don't have that array on that new system. So similar thing with what are called RAID cards. They will sell special PCIe cards you can slap in your motherboard, connects to multiple drives, and it's a dedicated card to handling RAID. But again, it's often tied to that specific manufacturer's implementation of RAID, and RAID cards themselves can also fail. So I generally recommend using software RAID. So this is where the operating system itself accesses the drives itself and then manages the RAID between them. Way back when, that was a bit more of a problem with CPU overhead, but with modern CPUs, the overhead hasn't scaled with processing power, so it's not really a problem nowadays. And we have advanced file systems that do fancy checksumming and all kinds of things on ZFS is probably the most popular. So I like ZFS a lot, so I'm going to talk about it a bit more. It's what I use at home. So ZFS, some mad lads at Sun Microsystems wrote it in the early 2000s. Sun was an interesting company. They got bought by Oracle, and now Oracle will sue you if you just even so much as like look at the logo. But as Oracle does, they came up with some great tech out of there, and they had a Unix-like operating system called Solaris, and ZFS was one of the things that came out of that, and it's now sort of made its way into open source with some re-implementations and relicensing. It's probably not going to get pulled into the kernel from licensing concerns, but it's still, you can download it as a kernel module. And it's specifically designed to maintain data integrity and access reliability. So it has some nice features like copy on write. This is a really cool thing where if you overwrite a file, it doesn't overwrite to that same data. It writes the new data somewhere else. So you can essentially have like Apple Time Machine like snapshotting. So you can say, snapshot the file system at this date, and it won't overwrite any of that data as you delete files and move them around or anything. And then you can just revert the file system to that date anytime. You can also send these snapshots over the network to another machine running ZFS, and you can even do that incrementally. So you can back up your entire file system, backing up only what's changed, and you don't even have to index the file system, so it can be quite fast. It doesn't have to go through and check every single file and upload it. It keeps track of what has changed at the low level of the file system and can send that along. And it can even do that while it's encrypted at rest, too. Yeah.
So do you have to do that as a snapshotting thing, or can you say, like, every time I write to this file, I want it to be a new revision?
So snapshotting, you would need to do snapshots between that.
Okay.
Yeah. So you could come up with ways to script that or whatever. But yeah, the copy on write is tied to the snapshotting. Yeah.
Is there like a conceptual difference or way to think about it that is different?
From my understanding, they are largely comparable. Jenna probably knows more about BetterFS than I do.
I have used both of those at this point and can tell you what the difference is. Would you like me to take this?
I think we can probably just keep it. Is BetterFS RAID 5 considered stable yet, or are people still? Okay. So basically, those RAID things I talked about, they don't work on BetterFS yet. They can delete your data. So ButterFS is still in development. It's people use it as their main operating system or main file system on their laptop, but it's not quite ready for showtime as a main server storage file system.
It's been very stable for many years now. If you're not doing RAID, it's just like a primary laptop disk. It's a nice ZFS Lite type file system.
Yeah, so you still get your snapshotting.
You should not use it for like heavy hitting RAID applications.
Yeah, ZFS is very mature. It's very well done. So there's not any of those concerns with that. So yeah, as I said, encryption at rest is quite nice, and you can do incremental backups. So you can have a backup server, and the data is always encrypted on your backup server, and you can still do incremental updates to your data to the backup server. It can chunk it up cleverly like that. Yeah.
I wanted to add, the cost you pay for that is ZFS does not encrypt the file system metadata. So things like file names and sizes are sensitive. ZFS does not encrypt that using its built-in encryption.
Okay, that wasn't actually something I was completely aware of, but
Which
fair thing
for
to mention.
most people's application, like that information isn't usually sensitive, but it's worth keeping in mind. That it's a trade-off.
Yeah. But it's nice though, because you could even have some backup server in the cloud, and you could not trust whoever has that, other than hopefully trust that they'll give you your data back if you want to restore your backup. But they can't read any of it. But you can still have these nice incremental backups. And it's rather multi-platform. Who knows if it runs on Windows? I sure don't. But it'll run on pretty much any Unix-based system.
There is an OpenZFS port to works fine. I've never had any issues, and it destroyed my entire Z pool.
Yeah,
So-
yeah. So use it on a proper operating system, and you'll be fine. All right, so let's talk a bit about the hardware, because you have all these drives. Now you got to kind of connect them. So I mentioned Synology. They make these pre-built NASs, and even TrueNAS will sell you a pre-built NAS. But many of you may want to, and I certainly did, DIY it, because you decide, oh, I don't need that much or this much of this, and you just want to throw together a PC and huck a bunch of drives in it. So pretty much all you need is a CPU and expansion slots. So your motherboard may run out of SATA slots. Many of them only have, let's say, 4 or 6, but sometimes they'll disable 2 of them if you put in an NVMe SSD. So if you want a fair amount of drives, you probably want to get one of those cards I have pictured there. So that is what is called a HBA card, host bus adapter. Basically, each one of those mini SAS ports there can become 4 SATA ports. So that card that's like $40 on eBay at most can run 8 drives from it, which is quite handy, and they're quite affordable. If you're going to get one, though, basically you can just search at the bottom there, LSI HBA card, but you want an IT flash one. It's just the mode they're going to flash it into, because these things I think can also do RAID weirdness. There's eBay sellers that specialize in selling these things, so you'll find what you want. But going back up the list, as I mentioned, you want to use multiple drives in RAID. And as I've already iterated, avoid hardware RAID. Just use soft RAID. It's really the way to go nowadays. There's a rule of thumb that gets thrown around a lot, because as many of you may know, operating systems will cache reads, meaning that if you read a file, it stores that information in any available RAM it has, so the next time you read it, it's really fast. So there's a rough rule of thumb that for reasonable accesses, you probably want 1 gig of RAM per terabyte of space, but I mean, it's just a question of the caching and everything. So it might just be slower for doing, random write intensive operations or things. And ZFS actually has some pretty fancy ways that you can cache. Sure, go ahead. Okay, I was thinking ZFS has some pretty fancy ways that you can speed it up with caches. So you can actually put an SSD in there, and that SSD can be a write cache. So your writes will be really fast, and then it on its own time flushes that cache to the hard drives. And you can also have a read cache that's an SSD. You want to, if you're going to do a write cache, though, you want to choose a very reliable SSD, because you can lose data if your write cache fails, and it's rather punishing to the SSD. You're writing a lot of data to it. So there are special enterprise SSDs that are good for this. You may even want to have like a RAID 1, basically, of these two, run the same data on both. So if one fails, you don't lose anything, things like that.
I did want to ask, and maybe you're going to get to this. I mean, you talked about, I'm a fan of ZFS as well. You talked about like favoring RAID 5 or RAID 6.
Yeah.
Do you have an opinion on like using RAID 5 and RAID 6 versus like RAID Z and RAID Z2?
So I did gloss over this. ZFS calls, it's basically the same thing. ZFS, I know there's subtle differences, but in terms of the topology of the drives,
Yes.
RAID Z1 is what ZFS calls RAID 5. So that's where you have 1 parity drive. And RAID Z2 is RAID 6. So you have 2 parity drives. So
RAID Z3.
did it even have RAID Z3?
RAID Z3 does exist.
Okay.
And I wanted to add just because critically in both 5 and 6, the parity information doesn't belong to a drive. It is striped across all the drives in such a way that any one disk is redundant.
Yep.
There is a RAID, I think it's RAID 4, where all the parity is stored on a separate
Okay,
drive.
yeah. There's some really weird
And
RAIDs
that-
that I'm completely ignoring because nobody touches them
You don't
anymore.
use that one because it turns out if you use one hard drive as a dedicated parity hard drive, the parity hard drive tends to fail a lot.
Yeah. I mean, there's there's RAID 2, there's RAID 3. They didn't just skip the numbers. It's weird, archaic stuff that frankly has no bearing on
RAID
modern
1.0,
things.
RAID 0.1.
Yeah, you can read the Wikipedia page if you want to know more about those. Okay. Yeah.
So for like something like a write cache, what do you think would be like good
It's really workload dependent how much money you want to spend. So depending on, if you're only trying to write small amounts, you could go pick up, they're discontinued, but you can still buy them. Intel had their 3D Crosspoint, like little 32 gig SSDs. They're ridiculously durable and fast, and they're not that expensive. So that probably a fair application for one of those. But if you need a lot more write cache, depending again on your application, then you're shelling out a fair bit of money for an expensive, fast SSD. So I'd say really it's oftentimes just how much you want to spend on it.
Which you probably don't need is like multiple terabytes for most.
Yeah, I don't.
Most personal workloads.
Yeah.
You just aren't going to be writing that much data consecutively without time.
Yeah, and I don't run a write cache, and I run virtual machines and game servers and everything off of my array at once. Like they still have a fair bit of performance. It's not like you're missing out a lot without a write cache.
Write caches don't start to make like a meaningful performance difference. I think it's like it's hundreds of terabytes or really intense workload.
Yeah, again, it's all quite variable. For most Homelab in use, though, just stick a bunch of drives together, and then you can maybe explore, past that. I wouldn't recommend it as building your first array with an intention to put a write cache in there.
Also, for something like a laptop Homelab, are there like alternatives to like PCI Express based SATA?
So I've seen some older laptops with like an eSATA port. Like I have one from 2010 that has one. You're not going to find that on modern ones. So unfortunately, in terms of like expanding storage from a Raspberry Pi or a laptop, you're kind of looking at those janky USB hard drive bays that I talked about. So
You
there's
could do something with the PCIe slot.
Yeah, the laptop wasn't the eGPU was included in that.
yeah, if you you could probably put that in a PCIe card in that. And then you get if you don't mind a bit of a Frankenstein thing around, which I mean, frankly, that's what my dorm looked like sophomore year when I started home labbing. So,
Yeah, if you're determined, you should be able to do like a drive card over encapsulated PCIe over Thunderbolt.
yeah, if there's a will, there's a way.
Computer you're using supports Thunderbolt. Probably.
It's an old, it's the framework for
It should.
Yeah. Okay. Mentioning a bit more. Oh, I have that title wrong. I meant to say backups here. Backups. I tried to drill that in, but backups are extremely important. Once you start having this amount of data, you will find in ways that you rely on that data being there, and it can be quite devastating if it just up and disappears. Okay, you don't want to lose your thesis, a month before your defense or something, or some other horror stories I've heard. So you can back up to the cloud. That's always an option. As I mentioned, there's ways to do encrypted backups, so you don't have to worry too much about what the cloud provider can see. Backblaze V2 is pretty good. So Backblaze runs like a desktop backup service, but they also have an Amazon S3 style cloud backup option. And they have pretty good integrations with a lot of backup tools, and their price per gigabyte is quite good. It's better than Amazon S3 and Google Cloud, that's for sure. So I think they're a fairly good option for that. Then, of course, there's the DIY route, which is what I went with. So have storage offsite. So what I did is, and it caused me problems, but for the most part, it worked. I had a Raspberry Pi at my parents' house, and it had a USB hard drive that ran ZFS, and I would send my ZFS backups to the backup. Now, my backup didn't have RAID. That maybe wasn't the best plan. I added RAID to it later, but that was at least my approach. So something that also gets oft repeated with regards to backups is the 3-2-1 rule. Okay, maybe I should have spelled it on the slide, but that translates to have 3 copies of any data you care about on at least 2 different kinds of media. So that might mean, in the past that kind of meant like, keep it on the drives and keep it on a tape, deck or something. Realistically, I think that's a little less critical nowadays, but maybe SSD hard drive mix probably counts as your laptop and your server. And then the 1 stands for one offsite. So if your house burns down, your data's somewhere, okay? I actually had some issues with my backup drive at my parents' house recently, so I had to take it back here. And right now, I just have a hard drive sitting in the drawer of my office in Loomis, and it has a ZFS image that I'll update every few months on it. That's my backup. I mean, you just need it to be somewhere, and also, you should test it, okay? It's not a backup if you haven't tested that you can access it. There's plenty of stories that get passed around of companies having like a decade worth of tape storage in a warehouse, and then they realize that there was a bug in their backup script, and they've been writing empty tapes for a decade. Okay, so test it. Double sanity check your backups. A couple programs for backup solutions: Restic, Borg, like I said, ZFS snapshots, rclone, or also just rsync for copying the files over. You can explore, these slides will go up in the Discord. You can explore these some more time just to sort of list a couple things you could look into for open source backup solutions. Do you have a question?
Is there a consistent way to like test backups? Like something that's automated?
I leave that as an exercise to the listener. There's probably some of these maybe have ways they talk about in the documentation. Other times it may be just building your own script and just doing it to whatever satisfaction you have. But
Two quick
sure.
suggestions would be, if you're using ZFS, not to harp on that solution too much, but it's kind of the choice in a lot of ways.
Mhm.
You should be able to get it to spit out data set checksums, some form, and confirming that all the data sets you're expecting to be there are, and that the hashes match is
Yeah.
probably good enough.
Yeah.
If you're doing it by hand with something a little bit less, a little more manual with something like rsync, comparing lists, walk the full file system and compare the files with something like Find.
Yeah, or just even making sure that like, oh, I did a backup last night and this file has a timestamp from last night. There's just some simple sanity checks. Or you could go to the slightly more extreme route, which you probably should do if you have like a job doing this in enterprise, is you actually like wipe a server and try to restore it from the backup, run through the whole process. Nothing like, you should test how you're going to do it in the actual crisis if you actually depend on it. Test like you fly is a saying that gets sent around in aerospace circles a bit. Okay. So moving a bit on from storage to actually some of the things you might want to do with it, because I've been talking about a lot, about 15 minutes left. Hosting online content. So this is something that many people may want to do with their servers. So web servers are quite common. You just want to host a web page. Again, there's plenty of services that'll let you do this, but you may want to run it yourself. So it's essentially running a website and all that entails. You write the HTML or whatever. You can host files. That's how I send very large files to my friends, things like that. There's some other software. Again, so we're going to reiterate. Nextcloud is something you may want to look into. You can kind of think of it as if you could host like Microsoft Office kind of things or like Google Docs kind of things on your own server. It's a little buggy. There are some rough bits around the edges because it's open source software. It's something we all committed to. But it's something maybe worth looking into. Okay, and of course, video game servers. And that's been almost easier than ever nowadays with Docker. And I'll talk about that in a little bit. So with web servers, Nginx and Apache are kind of the two main web servers that people use. You may have your own pet web server that you want to talk about to me and evangelize, but these are the main ones that you see in everyday usage. Instagram uses Nginx for load balancing. So basically, these are things you can just Google if you want to run a website on your computer. Okay, I'm not going to harp on them too much other than they present a website to whoever connects to your computer's IP address. Okay. However, if you're running a website, you probably want, especially nowadays since browsers complain about it a lot, as they should, you probably want that little lock next to your website. You want HTTPS. You don't have to go pay somebody like you had to 15 years ago. There is Let's Encrypt. It's a free service. You just have to set up a little program to answer some challenge to prove that you own the domain name that you're trying to get a certificate for, and then it just handles the certbot script handles the configuration of Nginx or Apache. It's very simple, and it'll run on, you can put it on a scheduled script, and it'll keep your certificate updated. It is easier than ever, and every website should have HTTPS with Let's Encrypt being a thing. So if you're going to run a website, you almost certainly want this. Otherwise, all your visitors are going to get a nasty pop-up complaining that your website's not secure. Okay?
It's not very niche. It's like one of the most common.
No, you're probably right. I think I've heard of Caddy. I don't think I'm not as familiar with it. So
It's the configuration is much easier than Nginx is the pro.
I would believe that. Yeah. I think a lot of things have easier configuration than Nginx.
Yeah, it's got it built in, so you just.
But Apache's worse.
In your config and it just starts working.
Okay. Yeah.
You don't do anything, right? You say you want a website that's already going to be HTTPS, like you don't have to
So-
make it special.
You gotta tell it what the domain.
Yeah. So we'll shout it out. Caddy, Caddy, I think. Yeah, something to look into. Probably easier than these to set up. Okay. And this is, again, Let's Encrypt. It's free and easy. If you have a domain name that's like owning a .com or .net, they're like $10 a year. If you can just come up with one that's not taken. I have lramsey.com and a bunch of other random ones I felt like having for some reason. But it's handy to have a domain name because otherwise people just have to connect to an IP address or something. So, make it easy to remember, make a domain name. Okay. So this leads a bit into networking. So if you want to run these connected services like web servers, you're going to have to deal with networking. Okay. The simplest level of these is just port forwarding. This is something you'll hear in every guide if you try to look up how to run a Minecraft server or whatever. By default, everyone's router, as it should, has a firewall to prevent incoming connections into your network. All port forwarding is telling your router to forward that connection to whatever computer you want to get that connection. So if you're running a Minecraft server, that's port 25565. So you would port forward port 25565 to whatever your server's IP address is behind your router. Okay, that's like just the most common thing you'll have to do before anybody can even access what you're running. All right, and that's the main thing that you'll have interacting with firewalls. You may get into more advanced usage later on, but your main encounter with firewalls is just opening little holes in them to let stuff through to access your servers. Okay. Another thing is proxying. So if you're running your Homelab at your home and people are connecting to your home network, that means they have to access your home IP address. So that may not be desirable if you're running some website that's like Google searchable, and then people just notice like, oh, this IP address seems to point to someone's house. Not always desirable. So my website, I proxy through another server. So this is where you can essentially, instead of the connection going to your router and getting forwarded to your server, it goes to some other server in a data center somewhere that you can rent for like $5 a month and then comes through to your website. Cloudflare also provides a proxy service specifically for websites, and it's free. So that, and VPNs as well, another thing that I'll talk about in a little bit. So routers, I already talked a bit about port forwarding. But router itself tends to become part of the Homelab. You don't necessarily find all the features you want in some off-the-shelf Netgear router. So, for example, I have the very masochistic setup of running OPN sense on a virtual machine with PCIe pass-through with a PCIe pass-through network card. Yeah.
I'm sorry.
So you may want to run your own router that has enterprise-like features, though. And there's operating systems for your router, because your router is just another computer and it routes connections. So why not make it a computer you can control and do whatever you want with? OpenWRT, shared around a lot. There are some consumer routers you can buy off the shelf at Walmart that you can run OpenWRT on. Oftentimes they're a bit on the older end because it takes some time for people to figure out how to load them on. But some manufacturers sell ones that are compatible with OpenWRT, like Netgear has a Linksys, which is Linksys, somebody bought Linksys, I forget who, but Linksys has an OpenWRT router that you can get. Other ones are OPN Sense and PF Sense. People actually tend to use BSD a fair amount for networking. I think it's because some of the first good firewalls were BSD, and it's got stuck around in the space a fair bit.
I mean, FreeBSD's networking stack is still a lot less jank than Linux's.
Yeah. But one notable Linux option is ViOS. That's kind of the main step up from WRT that's comparable to OPN Sense or PF Sense. Yeah.
I have a really bad router setup, which is one of Evan's old boxes that has like the sysctl forwarding flag turned on for IPv4. Have you?
Yeah.
And have tables.
Yeah.
Rules about that. What do these like enterprise solutions get me that I don't already have?
A web interface, so you don't have to manually set all that. Okay. Yeah, I have used a Raspberry Pi as my home router before, with manually setting the syscontrol for IP forwarding and manually setting the IP tables rules. I don't recommend it, because one time the ISP got mad at me because the Pi was spamming some ARP requests at their server, and they shut me off. A little embarrassing having to call them.
It's also good default that you get from using this. Like,
Yes.
Like correct.
The default will be sane and secure, so you don't have to worry about misconfiguring something and falling victim to whatever the next random botnet that's infecting all the IoT devices is. Okay. So these are good options if you want to explore. So Homelabbing a high-end router with a lot of features, like the same. Like I've worked at, like I did an internship at Battelle, for example, a couple of years ago. They're a rather large company. They have like a 15-building campus in Columbus. They use OPN Sense for routing. Yeah, these are high-end solutions that people do use. Okay, now I'll talk about one of the other common things people use in networking, switches. So a switch essentially lets you connect multiple Ethernet cables to one Ethernet cable at the most basic level, okay? There's a bit of subtlety in how they work, But at the basic level, if you don't have enough Ethernet ports in your router, you get a switch. Okay. At the most trivial level, there are unmanaged switches, which do just passively multiply an Ethernet port. But then there's fancy managed switches. And these can handle all kinds of things like VLANs. So you can have, 2 networks in your home network. One is just for the sketchy IoT devices you don't trust, and one is for real computers. And you can separate them out, and the switch can even do that separation for you. So that this subnet is on these ports, this subnet's on these ports. A normal unmanaged switch cannot do that. Okay. Speeds, also a fair thing to mention. So switches, gigabit switches are dirt cheap nowadays. You can get them for like $10. But if you're starting to push higher end speeds in your home lab, like 2.5 gigabit is kind of the next step people are going to, or even 10 gigabit, switches will get more expensive comparably. Because it turns out it's actually rather hard to 10x network speed. So we've been like a couple decades on 1 gigabit being the default. RJ45, you'll hear that thrown around a lot. That's just the name for the physical configuration of an Ethernet port. So you can largely conflate those two things if you're just Googling switches and you don't know a thing about them. But some higher end switches for higher speeds will have things called SFP connectors. So if you're going to do 10 gigabit, most of the time you're finding a switch with SFP connectors. 10 gigabit Ethernet is actually a lot more expensive. It's a lot more difficult to make 10 gig go over Ethernet versus a custom SFP cable. So if you're getting into budget high-speed networking, SFP switches are going to be more economical than 10 gigabit Ethernet switches. But it's really just another network port connection standard. SFP can do other fancy things, like you can put fiber transceivers in there, so you can do fiber between 2 connections with SFP to SFP. Very, very fancy. So if you want to do like a 5-kilometer network run.
What are people doing other than fiber for SFP?
The other option is DAC, which is literally just stand for direct attached copper. It's just a copper cable that just gets you a short throw. Usually those don't go longer than a couple feet though, because it's hard to maintain that signal integrity. So you'll find fiber often for longer runs. So
Like
building to
router
building here is
switch.
long haul fiber. Okay. Another thing worth mentioning, Wi-Fi. We all take it for granted, but you kind of can end up going down quite a rabbit hole with this. So all the enterprise router stuff I just mentioned, if you run like pfSense, that just runs on a computer. It doesn't really run Wi-Fi. I think nowadays sort of most people conflate Wi-Fi and router. They're like, oh, the router is the thing that has Wi-Fi. But no, a router routes packets. Wi-Fi is another medium it can route packets over, same as Ethernet. And if you go this route of having a separate computer as your router, you will need to give it a wireless access point. Okay? All these is that thing up on the ceiling there. It is a small computer that is specialized towards Wi-Fi, and it can handle pass-through from Ethernet to Wi-Fi effectively. A lot of times these things actually run stripped-down Linux on them. I can SSH into my TP-Link ones at home. Okay? Oftentimes, these enterprise access points actually aren't terribly expensive. You can get a really good one for like $80 online, and then you just plug it in via Ethernet to your router, and you have high-grade Wi-Fi. They often use what's called PoE. So when they run them out of these ceilings here, it's a bit of a pain to run like a 12-volt power supply jack to it. So they actually power it over Ethernet, PoE, power over Ethernet. So that's a whole standard. You can get switches that have power over Ethernet options, and then you just have to run just an Ethernet cable to it. That's all you need. You can even run Raspberry Pis on power over Ethernet with an extra add-on on top of them, which can be useful for some applications. And you can also sort of mesh these all together. So you've probably heard of mesh networks. You can have a whole bunch of little nodes throughout your house, but those use a wireless backhaul, which has all the drawbacks that wireless connectivity has with packet loss and other things. But you can basically get that by buying these wireless access points, these enterprise-grade ones, and just connect them all in the backhaul with Ethernet, and you'll get very strong performance. I even have only one of these running in my home right now. I used to have 2 at older homes I lived in, but yeah.
It's more related to the previous slide, but like, what's the difference between a managed switch and a router?
Good question. It starts to blur the line a fair bit, actually, because some managed switches can actually do routing and even like firewall rule applications. So it does get blurry at the high end.
I think the big idea is like managed switches can split broadcast domains, but routers do not. Like managed switches give you that layer 2 access that routers do not, right?
In terms of the speed, To a point, I mean, some routers can actually take advantage of hardware in the router to do hardware level switching, and it can communicate that to the OS. So like some network cards have drivers for these router OSs that can actually keep that mostly on card. So I would say reasonably spec'd routers can do everything a switch can. A switch is just going to be a lower cost, more specialized device for that. And as you go up in the cost on switches, you can get closer to router level features. Like you can have like firewall rule basics on some high-end switches.
So they can do NATs, like some high-end managed switches can do NATs.
Yes.
Okay.
Yes, I have seen that. Many of them have a much reduced switching rate at that because they have to actually inspect every packet. So it has to go all the way back to the CPU and back out. So typically they'll say, oh, this switching speed at this layer of networking, this switching speed at this layer of networking, and it breaks down like that. So a good company to look at for budget managed switches is Microtic, Mikrotic. And they have some pretty good options. You can get a 10 gig switch for like under 200, like $200. There's 4 SFP ports, and it can do some basic VLAN splitting. Yeah. So to finish up with wireless though, some of these wireless access points you can just kind of plug in and go, but other ones want like some controller software to kind of coordinate them if you have multiple of them. TP-Link actually has like GPL firmware on their access points. Like it runs Linux, and because it runs Linux, like you can get the firmware dump like it's GPL. I don't know to what degree their server is, the controller server, but it might be similar. I haven't run it in a while, so I haven't looked into it because they updated it recently. But that's at least what I use. A lot of people like Ubiquiti. The first time I bought Ubiquiti access points, they had a coil whine I could hear across the room, so I returned them and went with TP-Link.
So with TP-Link, they have a web interface usually, whereas like Ubiquiti and all the other enterprise ones don't. You have to buy the controller.
Okay, yeah, you're right. So you can run a TP-Link access point standalone. You don't even need the controller, and the controller, if you want it, is actually still also quite nice.
But Ubiquiti, you have to have the controller.
Yeah.
You can't use it on its own. It sucks.
Yeah. So yeah, I've set up ad hoc networks running off my laptop with just a TP-Link access point. Okay. So going a bit over time here, feel free to leave. I won't be offended. But to cover a couple of the last topics I had here, networking with VPNs. So VPNs, most people have heard of them. They sponsor every YouTuber on the planet now. But they aren't just for privacy. In fact, that's just one application of them. Ultimately, all a VPN is a secure network created between two distant computers. So they can effectively see each other like they're on the same network. One IP address can go directly to the other. It's just a virtual network that is private to those computers, VPN. So this is actually how I manage my website proxying. I have a server up in Chicago I pay $5 a month for, VPN it to my web server at my house, and then I just port forward from that server to my server, because you can just make it have routing rules. Okay, because it's a computer, you can do that. So if you want to run your own VPN, you can use WireGuard. I don't recommend OpenVPN. It sucks. You will spend hours pulling your hair out over why you generated your OpenSSL cert wrong. OpenVPN still sucks, and it sucked for years. WireGuard didn't exist when I first set up a VPN server, but now you should only be using WireGuard. There's an easy way to set up WireGuard on a Raspberry Pi. It's often the intended place, but you can install it on any computer called PiVPN. Kind of makes WireGuard a little easier, even though WireGuard's config is quite easy as it is. If you're comfortable with just editing a text file. Okay. Then there's also proprietary stuff such as Zero Tier, which does things a little fancier. You don't even need to open ports. It does some crazy stuff similar to how WebRTC works in Discord, and sends a packet to open up a temporary port and then establishes a connection two-way between them. And you can kind of just fire up a Zero Tier device on any network, no matter the firewall for the most part, and it'll be able to talk to all the other Zero Tier devices. So, yeah.
And there's also some, besides Zero Tier, you can also find products like Tailscale.
Yeah.
And I've had some issues getting it working properly, but in theory, Nebula is supposed to be a self-hosted option.
I use Nebula.
Okay.
I
Shout out to Nebula.
to work without using just a Lighthouse, without also using a relay.
The Lighthouse could be a relay.
Yes, but I don't want to put the traffic through the relay, because if I'm putting that up on a VPS, limited bandwidth. I
So-
would like it to just broker the connections, but I couldn't get that to work through like 3 layers of NAT because.
Yeah, so I mentioned Nebula is something else people look into. So to quickly finish up, I got 4 slides left, including this one. Security, that's a fair thing to mention because you are running connected services. You now have a bit of a concern about security. You don't want to just open all the ports, send them all to your server, and then never update your server. Okay, there are actually considerations of threat actors who just try to hit every server they can see on every IP address, hoping that one of them has that vulnerability running on an open port. So keep your stuff updated. If you do that, you're pretty much good for the most part. Like that covers a lot of bases. Most in the wild, widely exploited things are just things that have been fixed, but people haven't updated. Don't open everything to the internet. You can use a VPN server to connect into your Homelab and just have the VPN open if you're the only user, and you don't need to open those services up to the wide internet. So that's what I do for a fair amount of my stuff. And you may want to proxy certain services so they don't leave your home IP address, such as a website or other things that people could publicly find. Okay, I'll briefly mention containerization. This is a common way that people run these services I've been talking about. So you could have virtual machines on your server. So these are just virtual Linux installations. They're full Linux installation all the way down. And you can configure them a bunch of different systems to all do a different thing. But that's becoming a bit less common nowadays for people to virtualize every bit of their Homelab. And a lot of times people are just going to containers. Containers make things easy because you can just find a project. They say, yeah, just run our Docker container. And if you trust everything they have, which open source, many eyes, whatever, you can just run like 2-3 commands and then boom, the service is running. You don't have to go through, download it from your package manager, fight with the configuration for 3 hours. It can just run because you're running the same container that they're running. Okay, so it makes that very transferable. For some projects, you may need to grab Docker's version of Docker. At least Debian does not like packaging the latest version of Docker because Docker wants their own libraries, and Debian's particular about packaging. So yeah, so if you want to run some of these services, you may have to go add the Docker repository to your system. You can find guides online about it because some projects use newer features of Docker that have not been ported to the version that Debian or some others are running, just in case any of you encounter that. Okay. Getting near the end, so it's cloud services. I've talked a little bit about this, but has its place in Homelabbing. You can use it for proxies, you can port forward behind it. CGNAT is something I'll briefly mention. Sometimes the firewall that affects your connection is not just your router. Sometimes your ISP also has a firewall. CG means carrier grade NAT. So that means that you could open your port, but then people still can't connect to it because your ISP sucks. So in that case, your only option may be to proxy behind something else and have a public IP address off in a data center somewhere. I've never had an ISP do this, but I've heard of people who have. Okay, as I said, you want to keep your stuff updated. People automate some stuff like this with something called Ansible. You can kind of script certain administrative tasks. You can kind of have it run what's called a playbook, so it can run an update every so often, let you know if something went wrong with it, things like that, something to be aware of. Sometimes you may want to set up monitoring notifications. If you don't make a habit of checking your server often, you probably want some way to know that a drive has failed, so you don't let it sit there for 3 years like Linus Tech Tips did and lose all their data on their ZFS pool. So you can set up Gmail relays, so you can send an email from your Gmail account to yourself or something. You can use, I've heard of ntfy.sh. It's a pretty simple service. You can get a phone app, you send a post request to a web server, and you get a notification on your phone. It's pretty straightforward. Sorry, you have a question?
I've been trying to use Matrix for this because there's a decent Matrix command line.
Okay, yeah. Matrix, another option for all of the decentralized Matrix heads out there. And then also, if you have roommates and you're running the whole internet from your router, maybe think about hacking on it. When someone's trying to submit their midterm or something. If you have users, you start having to have other concerns. Like, I know I can't update my router at like 8 p.m. because everyone's in League of Legends, and I'm going to hear desks getting banged if it suddenly cuts out from an update. So you have to plan around some things like that if people start actually relying on what you do in your Homelab. Okay, and to end on it, I'm just going to list a couple popular services that people run. This is not a full list, but it's a list of things that you maybe just want to search up if they interest you. So yeah, of course, game servers. If you play the games, you probably already know whether servers can be run for it. Personal websites, you can make it part of your resume, other things like that. File servers, so if you want to connect to your storage on your server over a network, things like Samba, NFS, SSHFS, these are things to look into. on how to get that connection